Hello students, and welcome to this second video, which is going to go ahead and cover the second set of questions that are in our question bank. And this set of questions has to do with isotopes, but more realistically it has to do with electron configuration. And it basically gives us a statement, and from the statement, it has us wanting to work off of this information. It tells us that potassium also has two stable isotopes. Both isotopes have the same chemical properties. Explain why both isotopes of potassium have the same chemical properties. And so what we're going to want to do here is we're going to want to explain why it is, because we know that isotopes have different neutrons. They have the same number of protons, and they also have the same number of electrons. So what we're going to want to do to explain this is we're going to want to talk specifically about their electron configuration, because we think of protons as the particle that gives us the identity of the atom. We think of neutrons as giving us the mass of the atom or the different isotope of it. And we think of electrons as determining the reactivity, so all those chemical properties. And so, because potassium has two different isotopes, those electrons aren't going to change. So we would say that the isotopes of course we're going to spell isotopes, right? Of potassium share the same electron configuration. Therefore, they also share the same chemical reactivity, as it is the electron configuration which determines how a chemical or how an element will react. Okay. And that's how we would go ahead and answer that question right there. Okay? We're basically using the fact that we know that electrons are what causes all of our reactivity, and we're explaining that they have the same one. Okay? Next, it's wanting us to write out the full electronic configuration for potassium. So we'd have to go ahead and look at our periodic table, unless you have it memorized. We're going to see that it has 19. Okay? So that's the first thing that we're going to see. The second thing that I want us to take note of is that this one right here, it's in the S block, and it has an electron that's in the first column. So I know already, before anything else, that I'm going to go ahead and end with an S1. In addition, I know that I should end at 4 because it's in the fourth energy level. I know that this should end in 4S1. So I know that I have a goal as I'm going through here, okay? What we're going to do is we're going to go ahead and, well, first we'll get rid of our definition here, okay? And we're going to go in order, okay? And we're going to use our, cheat sheet here. We're going to, say this right here. We know that we don't have to go past 4S, so we're not going to go past that. We know that we're going to use 2P. We're going to use 3P. We'll put 3D here just because we know that we have to go at least to 4S. We won't use it, but I know I would probably write it just for comfort. And then we'll go 4P, and we know that our first energy level is going to be 1S. Okay, so we know we're going to draw 19 electrons. We're going to start with 1S, so we're going to go ahead and go 1S2. Our next energy level is going to be 2S2. Then we'll go ahead and see that we hit P, so we'll hit 2P6. 3s2. Then we are going to hit 3p6, and then finally 4s2. Oh, but then we notice, hey, wait a minute. I wasn't supposed to get 4s2. I was supposed to get 4s1. So I went over. So you see, I went a little overzealous here. Okay. And we should also be able to count up our electrons. Here we have 2, 4, 6. So we have 10, 12, 18, and 19. Okay. So this now fully answers the electron configuration for potassium. And now finally we have the 2-point question here. And this 2-pointer is basically asking us the first, second, and third ionization. So it's ionization. We automatically know, hey, it's taking electrons off. It's saying the first, second, and third ionization energies of potassium are 418, 3070, and 4600 respectively. Use this information to explain why potassium is in group 1. Okay, now for this question right here, we need to see any of our odd things that are going on. And we notice that right away, we see that we have a huge jump between this one and this one. Okay, like we have an order of magnitude jump. This is nearly 8 times bigger than this one. Whereas the second and the third one, it's not that big of a jump between them. It's not an order of magnitude jump between them. So what we would have to reference is we're going to have to reference that jump in and of itself. And then we're going to have to explain why that jump occurs. Okay? So it's wanting us to find the information that's odd, and then it wants us to explain why we have that information. And we already know that the information has to deal with the fact that the last electron for potassium is in this 4th energy level, and that when we remove this one, the next one's going to come from the 3rd one. And it takes a lot more energy to remove that electron from the 3rd one. So we're going to have to explain that, well, first it says why it's in group 1. We can tell that potassium is in group 1 because its first ionization energy is relatively low, and its second ionization energy is relatively high. Okay, so we know that's our reason. Okay, that's why we know it's group 1 automatically. Okay, now we have to explain why that information was useful to us at all. And the way that we're going to go ahead and do that is that we're going to go ahead and use kind of like our electron configuration here, or that energy level. And then we're going to go ahead and use shielding in our answer as well. Okay, and that's because this electron here is being shielded by the first energy level, second, third. Okay. So now we're explaining that the outer electron for potassium is in the fourth energy level, which is what we wanted to do. And we're also explaining why it's easier to remove. Now we have to remember that we have to put that it is easier to remove. So then we're going to go ahead and put comma and then therefore it is, or it costs less energy to remove it from the fourth energy level. Opposed to the great amount of energy needed to remove an electron from the third energy level. Okay. So here we have it. We have our answer that makes sense to us, that this first one is easy because it's in the fourth energy level. It has less shielding than all the other ones. And therefore, it's going to be easier to remove that one, whereas removing one from the third energy level is going to be much harder. Okay? And that's all that we have to do to answer that one there. While we're here, we can go ahead and we'll take just a quick peek at the next ones. Okay? These ones are looking for protons and electrons, just having us count. And then this one is talking about the shapes of orbitals. And so those are the ones that we can go ahead and look forward to seeing those done later on. At this point, have a wonderful study session, and I hope everything meets you well.